Okay, so we've reciprocated the zeros of tangent to become asymptotes, the asymptotes to become zeros, and when we reciprocate 1 and -1, we just reflect it. So it's tangent translated over pi over 2, yes? And then just when tangent is increasing, cotangent is what? Decreasing. It's the only difference between the two. So let's do domain, range, all that fun stuff. So cotangent. So the domain.
So x such that cannot equal.
Where are my asymptotes out here?
2 pi.
0, pi, 2 pi. So this is where we cannot equal that plus or minus pi n. What was that the same as?
Secant.
Secant. And range?
All real numbers.
All real numbers because it extends to from negative infinity to positive infinity. The period?
Pi.
Pi. Amp?
Not applicable.
Okay, so in your homework last night, it had things like cotangent. Can you see that down there? Yep. Cotangent of x equals 1. Okay? So cotangent of x equals 1. So we're looking at the green, right? So it's 1 at pi over 4, right? So x equals pi over 4. And it said from negative 2 pi to 2 pi, that's why we used this graph. Okay? Well, how far is this one to this one? Pi, because that's the period, isn't it?
Yeah.
So I would add pi to this and get 5 pi over 4.
Oh, we need all of them?
Yep, it said in the directions, it said from negative 2 pi to 2 pi. And then, do I have any more positives?
No.
Nope. So then I got to go negative, so that would be negative 3 pi over 4. And then negative 7 pi over 4. So that's what you were just supposed to use your graph to do those, to find those. So after I did this, are there any further questions on your homework last night?
Not anymore.
Okay. So, depending on, like, anything for tangent, I think you only had 4 answers. And that would work for cotangent also. Actually, how many answers would I have if I said tangent of x equals 0?
You'd have
Tangent was the blue, right? How many answers would I have? 1, 2, 3, 4, 5. So x would equal negative 2 pi, negative pi, 0, pi, and 2 pi. Again, just once you find one of them, all you have to do is add and subtract the period, correct? Could I keep finding these answers forever without a graph?
Oh.
Yes, just add the period. That's it. So before we go on to the next thing, I'm going to give you just about 5 minutes, and that's it, to fill this whole thing in. Okay, now, this is, I don't even have the whole thing on here. It goes 0 to, guess where? 360. You're going to write them in radians. You're going to do the sine, the cosine, and the tangent. There's only one quadrant, and all the rest repeat, correct?
Yeah.
This is not a race. I'm just only going to give you 5 minutes to do it, okay? I am going to do it at the same time you do it. I guess if you feel the need just to copy mine, then that's what you feel. But this is what is 75 points on your final exam. Okay? So I would make the attempt to do it yourself. Okay?
Will it be
We
exactly
will-
like that?
What?
Will it be exactly like
Yeah.
that?
Just because it's easier to put it like that. I would attempt it yourself. There is a second one on the bottom. So when we go back over it, if you need to just start over, you just start over. I'm not going to give you time to copy this, nothing like that. We're going to 5 minutes to do it. We're going to talk about it. And when we're talking about it, is not the time to be copying it. Am I understood?
Yes.
Okay, you can do that on your own time. When if you don't get how to do this, you probably should be talking to me one-on-one at this point in the game. Right? So this is to aid us in the next part of our notes. So I'll pause that. Stop. Okay. If anybody was watching how I did I go like this?
You did not.
I did not. I actually did them in the color groupings that I have. Sometimes I'll go and do all of my my radians first, and then I'm like, yeah, no, I won't. Okay, so I first started with my quadrantal. So I put my points. I put 1, 0, 0, 1, negative 1, 0, 0, negative 1, 1, 0. I just wrote my quadrantal points there. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I went, sine is my y, x is my cosine, correct? So 0, 1, 0, 1, 0, undefined, 0, negative 1, 0, negative 1, 0, undefined, 0, 1, 0. Then I did 30, so that's pi over 6, because 30 goes into 180 how many times? 6. Then over here, 150 is 1 less than a whole pi, so it's 5 pi over 6. 210 is 1 more than a whole pi, so 7 pi over 6. And then 330 is 1 less than 2, so 11 pi over 6. Then I didn't do what I normally do. Before I even do that, I normally put my positive and negatives. You saw me do it after I did my 30s. I went through, and in the second quadrant, it is from here to here. Cosine and tangent are negative. In the third quadrant, sine and cosine are negative. In the fourth quadrant, sine and tangent are negative. I put my negatives there, so guess what I didn't have to do again? Did I have to think about them at all? No. So then I just did 30. Okay, opposite of 30 is 1. Square root of 3. Square root of 3 over 3. So then all I have to do that is take that to every single one of my what? 30-degree angles. I thought about it how many times? Once. And then I went to 45. Square root of 2 over 2, square root of 2 over 2, 1. And repeated that for 3 pi over 4, 5 pi over 4, and 7 pi over 4. Yes?
So how do you remember, like, which one, like, say, how did you remember 7 pi over 6 goes next to, like, after pi?
Well, because how far they are, the reference angle. Pi is 180, so 150 is 30, 210 is 30, so they're 30-degree reference angles. Is that what you're asking?
Yeah.
Okay. And then 60 is pi over 3, so 60 is 120, which is 2 pi over 3, 240, which is 4 pi over 3, and 300, which is 5 pi over 3. And I have square root of 3 over 2, 1/2, and square root of 3. Just by what is opposite, what is adjacent, and opposite over adjacent. And then I just repeated that. So again, am I really doing this whole thing? No. I do the quadrantal angles, I'm doing one quadrant, and then I move on. Okay? So that is recorded. I will post it so you can watch it if you need to. So what we're going to do today is 4-7. We're going to use inverse trig functions. Okay? So inverse trig functions, we have a problem. I'm going to show you sine. This is the red, right? Is this a function?
Yeah.
What test does it have to pass if it's a function?
The vertical line test?
Okay, does it pass the vertical line test?
Yeah.
Yes. Is its inverse a function?
No.
No, because it doesn't pass the what?
Horizontal.
Horizontal line test. So we got a problem, don't we? Because we need inverses. Because we need to be able to use these functions to find angles. But we can do this wonderful thing. Instead of making the domain all real numbers, we could cut the domain. If I cut it from here to here, from there to there, do I have all the positive values of sine?
Yeah.
Do I have all the negative values of sine? Yeah? Now, is this little chunk a function?
Yeah.
Is it a 1-to-1 function?
No. Well, yeah.
Yes. Does it pass the horizontal line test?
Yeah.
Just right there, doesn't it? Okay.
But it doesn't pass the both.
Yeah, it does.
It does?
Yes.
Those are two different functions. Or
The
other part.
red.
Oh, I was
Okay.
looking at that.
So now my question for you is, if I do that, look at my cosecant. Is that now a function? And a 1-to-1 function also?
Yeah.
Yes. I've cut it right there, haven't I? So what quadrant is that?
One.
Somebody just-
This is 0 to pi over 2, so that's quadrant 1.
Yeah.
And this is 0 to negative pi over 2, so that's quadrant what? 4. So what we're going to do with sine no longer exists in our whole circle. I'm going to take and basically say this doesn't exist and this doesn't exist. So sine only is going to exist from 0 to pi over 2. That's a 2. I was thinking ahead in my process. And that's 0. And from 0 to negative pi over 2. Now, the reason why that's not 3 pi, I'll zoom that back in, sorry, 3 pi over 2 anymore, is because 3 pi over 2 shows a movement, yes, around the circle. Well, can I go around the circle when I've said it doesn't exist anymore? No. So we are going to restrict restricted, that sounds weird, but a restricted sine domain, and now it is a capital S. Is x such that negative pi over 2 is less than equal to x, which is less than equal to pi over 2. Because that's all I've said exists, isn't it? Now, is the range still negative 1 to 1?
Yeah.
Yeah, the range is still negative 1 to 1 because I didn't take anything out. Could I have done that if I excluded anything from the information? No, because it wouldn't be the whole function. But what that allowed me to do is to make my inverse also a function.
Yeah.
Now, instead of having multiple solutions, I now only have one set for positives and one for negatives.
Wait. Couldn't that be plus or minus pi over 2?
No, it has to be written from negative pi over 2 to pi over 2 because it's everything between. So when I have a positive answer, it's going to be in the first quadrant, yes. When I have a negative answer, it's going to be in the fourth quadrant. And I've included every answer I need. Make sense?
Yeah.
So what about cosine? It's cosine, right?
Yeah.
If I restricted cosine from negative pi over 2 to pi over 2, would that work?
No.
No.
You don't have the negative.
I don't have any of the negatives. And I can't restrict if I'm going to lose answers, right? So let's see if we can find a better one. What happens if I just do this?
From 0 to pi.
From 0 to pi. Does that work?
Yeah.
Yeah?
So that's how you pick what domains you restrict, just whatever will work
Right.
for
When
both to make it a 1-to-1 property.
Right.
Whatever domains make it work.
Yeah, whatever domain is, because we want everything. I personally tell you that you have to restrict it so it is a continuous graph. And I'll show you what I mean by that. Like, because this is continuous. That asymptote is for secant, not for cosine, right? So when we get to tangent, I'll explain what I mean to you by that, because sine and cosine are both continuous graphs in general. So we are going to restrict cosine.
May you move your paper up a little bit, please?
Sure. To what two quadrants then?
First and fourth.
No, not cosine. You guys told me we were going to go from 0 to where?
Pi.
Pi. So what two quadrants is that?
1 and 2.
1 and 2. So what two quadrants are going to go away?
3 and 4.
3 and 4. So we are going to have from 0 to where?
Pi.
Pi. So our restricted cosine, again, a capital C now. And this is why I got after you guys when you use capital C's and stuff like that. When you use the capital letter, it tells people you are only looking at the first and second quadrant. If you were using the lowercase, you're looking at, this pen keeps wanting to get in the way. You are looking at all of it. So our restricted domain is x such that 0 is less than equal to x, which is less than equal to pi. So again, we have all our positives in the first quadrant and all our negatives in the second. So we've covered everything, right? So now all we need to look at is what? Tangent? Okay, and I already have a circle drawn. I'm doing good. Okay, so tangent is the blue again, right? I will tell you in books, you will see this graph from 0 to pi for tangent. Okay? My problem with that is between 0 and pi is that a continuous graph?
No.
No, it's not. And there's nothing wrong with it. But wouldn't it be nice to have a continuous graph?
Yeah.
So instead of going from 0 to pi, couldn't I go from negative pi over 2 to pi over 2?
Yeah.
If I did that? That, to me, maintains the shape of tangent in my brain. Because we need to know what that parent function looks like, right? So we are going to use what restricted, what quadrants then? If it's negative
1 and 2 and
1 and 1 and 4. So these don't exist anymore. So from pi over 2 to negative pi over 2.
How do you know what quadrants to restrict?
Yeah.
Well, first of all, it has to be around 0.
Mm-hmm.
Okay? And again, there are many times that they will tell you tangent, they're restricting it from 0 to pi. Okay? But I like to have that continuous function so I see the shape of tangent. So I could have restricted this to 0 to pi, but we're going to restrict it from negative pi over 2 to pi over 2.
So the domain would be the same
As what?
Sine?
Right. So tangent domain is the same as sine restricted. So is x such that negative pi over 2 is less than equal to x, which is less than equal to pi over 2. So again, what that does for us is you guys were using inverses yesterday. When it said tangent of x equaled 1, you were saying where is tangent 1 at? That's the inverse. That's flipping the domain and range around. That's what inverses do, correct? So now instead of having 5 answers here, I'm going to have 1. And that answer would be 0, wouldn't it? In that new domain, it would be 0.
Yeah.
So that's what it does for us. All it does. Now, inverses also allow us to switch domain and ranges. I was going to highlight on this what we restricted it to, but it doesn't work. Well, it does. Okay, so if you want to get a highlighter, we restricted cosine what two quadrants?
First and fourth.
0 to
0 to
pi. So that is
First two quadrants.
first 2 quadrants.
From 0 to pi.
Yep. Okay, we restricted cosine from 0 to pi. What did we restrict sine to? I gotta zoom this back out. Sine was the first and the what?
Negative pi over 2 to pi over 2.
Okay, so the first and the fourth quadrant. So you need to highlight the first quadrant. Oops, I went too far. And then go to the end and highlight the what?
4.
The fourth, thank you.
Or highlighting takes a lot of concentration.
Yep. And when we're doing this, thinking about this, this is no longer 3 pi over 2. It is what for us now? Negative pi over 2.
Yeah.
So this is negative pi over 3, negative pi over 4, negative pi over 6. Because we're rising and falling. Don't like this end, it's going to bug me. Okay.
Is there ever going to be a time where it'll go second and third quadrant?
No, you can't skip over a quadrant. Thank you for asking that question. You can't skip a quadrant.
It'll always be first and...
It will always be, now, yeah, you can't, like, I guess it could if you want, I've never seen it done, but you could do like second and third for sine, because that would be all your positives and all your negatives, but then you wouldn't have 0. Does that make sense?
Zeros over.
Yeah, so, okay, and tangent was also what? First and, oh, I'm going to highlight green over green. That didn't work too well, did it? I bet you can't see it. Well, doesn't she know you're in school?
I don't know. Does she need something from me? Because we're in math class.
Taylor, were you on your phone?
Yeah, what's she saying? I don't know. I don't know.
Okay, so now you might want a piece of paper. So I keep, what? Okay, well, hurry up and highlight. You can go back and highlight.
I can't do that.
Okay.
Highlight. I have a highlighter.
Okay, it's fine. She doesn't have to highlight.
Yes, yeah. She did, so I could look off her paper.
Okay.
That's cheating.
Shut up.
Okay, so if you're starting a new one, we're 4-7 and inverse trig functions. So sine of x is what 2 quadrants now?
First and fourth.
First and fourth. I don't even draw the other 2. So pi over 2, 2, negative pi over 2. Cosine of x is now what 2 quadrants?
First and second.
First and second.
would you call for?
Because next time you two are standing outside the school building for 5 minutes because no one's in the office and the door's broken, don't call me.
Miss Smith,
I
said
was-
that.
Okay, we were in class, Helena.
That was Miss Mick's fault, not mine. I wanted to answer.
So 0 to pi.
I've been here 5 minutes ago. She would let you answer.
Sorry, that was my mom's fault actually, because Karen's gone.
So tangent is what 2 quadrants now?
First two, yeah, first and fourth.
First and fourth. So going up to pi over 2 and down to negative pi over 2. And I'm going to keep stressing that because somebody's going to want to tell me the answer is 11 pi over 6. Does 11 pi over 6 exist anymore?
No.
No, it would be negative pi over 6 because we're rising to pi over 2 and dropping. So there are 2 ways to write inverses. Inverse functions. Inverses, I don't know if is a word. The first is arc, sine. So also it would be arc cosine. It would be arc tangent. There would be arc secant, arc cosecant, but I don't know why you would use those. The second is the way we have done it before with just the negative exponent, negative 1 exponent. That is the way that it is on your calculator. I'm going to tell you probably on your ACT here in a couple weeks, they're going to put an arc.
Say that.
Okay? They're going to throw an arc on there just to see if you know what it is.
So that just means inverse.
It just means inverse. That's all it means. So remember, inverses interchange range and domains, correct? So if I have the sine of x equals a number, yes? And x is an angle. When I take the inverse sine, what am I doing? Going to be inverse sine of the
What is that?
number equals the x. And x is the angle.
Yeah.
So we have found the sine of 30 degrees. We found the tangent of 45 degrees. But now I'm going to give you a tangent and you have to tell me the angle. So all you have to do is take the inverse of it. Correct?
Yeah.
That's it.
Shouldn't be too hard. Maybe it is.
So I have arc sine of negative 1/2. Now everything we do in here is restricted domains in this section. Okay? I will write a capital S when I'm asking that question. The book always will not. It always won't. But anything we do in 4-7 is with restricted domains. Got me? Okay. So, sine is what in what quadrant?
Sine is first and fourth.
First and fourth. So, first and fourth. It's negative, so which quadrant are we in?
We are in the fourth.
We're in the fourth. So, we're right here. So, you know where the sine is 1/2 at. Where is that at?
Going at 4.
No. What angle
Oh.
is sine 1/2 at?
30.
30. Thank you. What's opposite of 1? 30. So we're in radians. So pi over
That's it, letter.
6. But I'm not going up pi over 6. I'm going
Down.
down. So it's negative pi over 6. I take my chart and I'm sine and I need negative 1/2 is at negative pi over 6. You're not going to use the chart. I'm not going to give you the chart to use on a test. You know where sine is 1/2 at. The reference angle is pi over 6, correct? So then you have to apply it. This will help you check it, but I'm not going to allow you to have that. That would be silly.
That's sad.
Okay, the inverse sine, one last one before we go for today, of square root of 3 over 3. Well, the reason why it's square root of 3 over 3 is because the square root of 3 was in the denominator, correct?
Yeah, and it got reciprocated.
Oh, that should be a 2. I wrote down the tangent one. That can't be. Never mind.
I was like, what?
Disregard. Disregard my words. Okay, so opposite of square root of 3 is what angle?
That would be 6.
It would be 60, so it would be pi over what?
Pi over
3.
3. I'm giving you the value. I'm now asking you the what? Angle. Inverses find. Inverses find what?
angles.
Angles. So if I'm asking you to do the inverse, you're finding a what? Angle. You think this is important?
Yes.
Yes. Okay, you don't have homework today. We will finish notes tomorrow, and you'll have homework tomorrow.